Welcome back to my channel. Today, what we're looking at is finding zeros of polynomials. So basically, we're dealing with some quadratic situation here. So whenever we're going to find zeros, we want to make sure that our quadratic is equated to zero. For example, we're going to put zero where the y is right here. So if we should rewrite this, what we really have is a 5, and this is equal to 0. Now, we have multiple ways to solve this, but I do realize here that we could solve by factoring. See, we're going to factor this by the AC method very quickly. So what is our A? Our A is 5, our B is 14, and C is -3. We definitely could find AC, which means we're going to multiply our A value times our C value, and we're going to get -15. So basically, we're looking for two numbers that are factors of -15. So when we multiply them, we're going to get -15. And when we add those same two numbers, we are going to end up with +14. Okay, so this would have been our AC and our B here. And that's what we're looking for ultimately. So let us take apart these, right? So 15 times 1 is our first factor pair of 15. 5 times 3 is our second and last factor pair of 15. So the thing is, it's going to be a limited number of factor pairs that we have. So which one of these could give us a 14 by adding or subtracting? You could see that 15 and 1 could give us a 14. So we're going to focus on that. Remember, though, that when you multiply them, you should get -15, but add, we're going to get +14. So it means we're going to have to use -1. So we're dealing with +15 times -1. So we get our -15, and +15 plus -1 will give us 14. So we're going to substitute these two numbers here for the middle term right here. So let us go ahead and set that in. We're going to rewrite our 5x squared. And then I'm going to substitute for the +14 is going to be +15x minus 1x. And then we're going to put back our -3, and this is equal to 0. At this time, you could split these down the middle if you want. And then we're going to factorize each by the highest or the greatest common factor. For example, we are seeing where 5x could work here. So we're going to take 5x and then open a parentheses. We're going to divide throughout by 5x for these two right here. So 5x into 5x squared, we're left with x. And 5x into 15, we're left with +3. And then now, as you could see, we almost have the same thing. So -1 seems to be a very good number that we could use. So we're going to be using our -1 here. And if we divide throughout by -1 here, -1 into -1x will give us +x. -1 into -3 will give us 3. And this is equal to 0. Again, we're going to factorize because we're seeing common factors here now. Our common factor is x plus 3. So we're going to take out our x plus 3 right here. And as mark you, if I should divide through it by x plus 3, you could see that it's going to cancel itself. So 5x will come down. And if I divide this by x plus 3, you're going to see that it cancels itself, leaving -1. So this is equal to 0. Now, two things multiply to give 0. We have to apply that zero product rule. So it's going to be either x plus 3, that is equal to a 0, or 5x minus 1 is equal to 0. In solving them, we're going to subtract 3 from both sides. So x is equal to -3, and that's one solution. If we add 1 to both sides here, 5x is equal to 1. Divide both sides by 5, we're definitely seeing that x is equal to 1/5, my second solution. So the solutions are x is equal to -3, or x is equal to 1/5. And there it is. We solved that. Let us take a look at a second problem. So in this second problem, we're looking at 4x squared minus 12x plus 9, and that's equal to 0. Now, we're still going to be using our AC method here because we can factorize. A is the coefficient of the square of x, that's 4. B is the coefficient of the x, and that's negative 12. And C is our constant, which is 9. We're going to find our AC. So 4 times 9, that gives us positive 36. Remember the idea that these two numbers that we're looking for, they're factors of 36, which is our AC. They will multiply to give us our 36, which is our AC value. But if we do add them together, we will get the middle term, which is negative 12, and that's our B value. So we want to look for the factor pairs of 36. We could list them. 36 times 1, then it could be a 9 times 4. It could be a 12 times 3. Well, it could be a 18 times 2. And it could be a 6 times 6. So all of these are the factor pairs that could give us 36. So what we want to do is we want to see which one of these could give a 12. Like if you add or subtract, this cannot give a 12. This could give 37 or 35. This could give 13 or 5. This could give a 9. It also could give a 15. This could give 16 or 20. But this could give a 0 or a 12. And we're looking for a 12. So it's going to work. So let us isolate this. We're looking at 6 and a 6. So here is the thing, though. They should multiply to give us positive 36, but negative 12 when we add them. So because we need this negative 12, it has to be negative 6 times negative 6. And that's going to give positive 36. And then negative 6 plus negative 6 will give us negative 12. So this would have satisfied the condition. We're going to replace negative 12x by negative 6 and negative 6. So let's rewrite this. So 4x squared minus 6x minus 6x plus 9. And this is equal to 0. We're going to split this down the middle right here. We're going to split that. We're going to take out a 2x, which is the greatest common factor of these two terms to the left. So we're going to divide these by 2x, divide these by 2x. Now let us divide. So 4x squared divided by 2x, and that's going to give us 2x. Negative 6x divided by 2x will give us negative 3. Close the parentheses for that. Negative 3 seems like it works here. So negative 3, open bracket, or parentheses. We're going to divide by negative 3. We're going to divide by negative 3. So negative 3 into negative 6x is going to give us a positive 2x. And negative 3 into positive 9 will give us negative 3. So this is equal to 0. Again, we're noticing that the parentheses would have the same 2x minus 3 inside, which means that this is our common factor. We're going to isolate our common factor, 2x minus 3. We're going to divide each term by 2x minus 3 by 2x minus 3. Over here on my left, you could see 2x minus 3 cancels itself, and we're going to be left with 2x. And when it cancels itself here, we're left with negative 3. This is equal to 0. Remember, though, that when two things multiply to give a 0, we're going to have to apply that zero product rule because it's either 2x minus 3, that is a 0, or it's a 2x minus 3. We definitely see that we're seeing the same thing. We'll talk about that in another video. So basically then, if we're trying to solve this, what are we looking at? We're looking at 2x, which is equal to 3. We divide both sides by 2. Then x is equal to positive 3 divided by 2, or 1.5. And you can see this is the same thing. 2x equal 3. X is equal to 3 divided by 2. And so we have equal roots. Basically, what we have is that x is equal to 3 halves, or what we call 1.5 right there.